Hi, this is Group 2 of B1 slot. Our topic is keyboard interfacing with 8051 microprocessor. In this presentation, we are going to tell about how to interface 8051 microcontroller with the keypad. So the contents are introduction, working principle, components required, programming for microcontroller, and applications. We used Atmel 8051 microcontroller, and keyboard is one of the best input device nowadays from very ancient time. So interfacing microcontroller with keyboard makes it faultless and makes input rate faster. So most of the inputs we are giving in using keyboard itself. That's why we have to know how can we interface keyboard with a microcontroller. And how did we our keypad is a hex keypad. Like matrix keypads are also well of the simple architecture, that's why I used a hex keypad. Hex keypad is can be given as an input because it has less number of keys and easy to understand. And hex keypad has only 16 keys, as you have seen in this diagram. It has from 0 to 9 and A and F. So the labeling is done in hexadecimal format. Two approaches, column scanning and row scanning, are there because a matrix has columns and rows, and the press switch makes the corresponding column and row sorted, and this is how we interface. Here we connected with the port 1 of the microcontroller, and the output is driven to an LCD output with the port 0. Port 0 here we used an external interface, as we can see. So these are connected through an resistors, and the frequency of the microcontroller is 11.0592. So we know that 8051 microprocessor has an 8-bit CPU and 4 KB on-chip memory and 128 bytes of on-chip RAM. Two 16-bit timers are there, and serial port is full duplex, and it has an on-chip clock oscillator whose frequency is 11.059 frequency. This is the 7-segment display. The extra thing we did, the other components we used are, these are the values of the other components used, and this is the program in C. We in assembly language we used to interface the microcontroller with the keyboard. We used DPTR LUT, moves the starting address. Here all the details along with the comments is neatly written. And we use the delay calculations because to make the state stable for some time. And these are the looping, and the output is given to the port 1, as we can see here. And the main problem we faced are switch contacts do not come to the rest immediately after pressing. So microprocessor sends multiple key press due to multiple pulse generation. A human cannot press and release a key in less than 20 milliseconds. The rate here we used to switch these keypads is very less when compared to the frequency of operation of the microcontroller. So we have two approaches to reduce these problems. One is hardware problem, one is software problem. These are the small other problems. The basic calculator we used are multiplication, subtraction, and addition. As we can, these are 16-bit. So we have kept 0 to 9 10 digits of that, and four keys for operating plus minus into division, one equal to, and one for switching on and clearing the bits of the calculator. Yeah, this is the overall block diagram of our thing. The 2 digits also similarly, in this way we can use 2 parallel hex keypads for larger bit addition, and we can display those 2 bits with 2 LCD displays. Thank you very much.
Windows to shift to